The following question asks us, for each pair of elements, indicate which one you would expect to have the greater first electron affinity. So the first thing that I want to point out is, what is electron affinity? Electron affinity is the likelihood of an atom to accept an electron in the gas phase. When it accepts an electron, it's going to become more negatively charged, and this is going to be an anion. Remember, anions are negatively charged ions. So let's go ahead and first talk about a few things with electron affinity. The more positive the electron affinity is, the more favorable that this reaction will actually proceed. So in the case for part A, we have aluminum and silicon. So let's go ahead and identify where these are on the periodic table, and let's draw out their the orbital diagrams for each of these two elements. So aluminum is right here. So the electron configuration will be neon, 3s2, 3p1, and let's go ahead and draw out these diagrams, because this is really going to help us determine which one's going to become the most stable for accepting a electron. And then neon, 3s2, 3p2, remember to follow Hund's rule when you place in your electrons. So in each of these two cases, let's determine which one's going to be more favorable in accepting an electron in this case. So if aluminum accepts an electron, it will be added into an empty p orbital. If silicon accepts an electron, it will be added into the empty p orbital that it has. So in this case, if silicon accepts an electron, it's going to become more stable because it's maximizing the spin. So following Hund's rule, it's going to make it more stable. When in the case of aluminum, by it accepting an electron, it's not making it more stable in this case. You're actually going to increase the repulsion in this scenario. So it's going to be more not as energetically favorable. So in the case between aluminum or silicon, silicon is going to have the greater of first electron affinity because it's going to be more favorable than that of aluminum. Remember, the more positive your electron affinity, the more likely for your reaction to occur. So in the second case, they're asking us which one would be more favorable, silicon or phosphorus. So let's go ahead and write that phosphorus for its orbital diagram and its electron configuration. It would be neon, 3s2, 3p3. I think you can already guess which one's going to be more favorable in this case. This was A. So if phosphorus accepts an electron, it will then become paired with one of the half-filled orbitals that are there. And if you look at the two of these, this between silicon and phosphorus, you'll note that silicon is still going to be more favorable to accept a single electron than that of phosphorus, because silicon has an empty orbital in which to accept that one electron, and this is going to be more energetically favorable and more stable, whereas this one is not going to be more stable. It's not really increasing the stability of its structure, and it's actually making it less energetically favorable. So in this case, in part B, silicon would have a greater first electron affinity than that of phosphorus.